This is the screencast for section 2.8, example 1. We're going to find where a polynomial is 0, positive, or negative. So here is the polynomial f of x equals x plus 3, x squared plus 1, and x minus 4 squared. So you can already tell what the zeros are. Negative 3, this would actually be negative I and positive I. And then this would be 4 with a multiplicity of 2, so the graph is going to bounce there. We have this really cool tool called a sign chart. So to start my sign chart, I'm going to put down a number line, and on that number line I'm going to put the real zeros in increasing order, just like a number line would be. And now I'm going to put parentheses that represent each little quantity in the polynomial. Parenthesis, parenthesis, parenthesis. So 3 sets of parentheses. Now, this is supposed to be negative 3. Take any number to the left of negative 3. So negative 4, negative 5. I think bigger numbers are easier. Well, I guess they would be smaller numbers because they're negative. But like negative 100 is very easy to think about. Because negative 100 plus 3, I don't care what that is, that's definitely negative. So I'm going to put a little negative sign in that first set of parentheses because whatever number I plug in to the left of negative 3 would be negative. Take that same number, negative 100, square it, you get a positive, and then add 1, so that would still be positive left over. Now take that same number, or it could be any different number, doesn't matter. Any number to the left of negative 3, subtract 4, and then square it, you're going to get a positive. Overall, when you take the first negative times the positive, well, let's see, a negative times positive is a negative. So then a negative times that positive would be still negative. So now overall, any number I plug into the function that is left of negative 3 will have a negative y value. So the output, f of x, will be negative. When I plugged in negative 3, I got 0. Now let's plug in anything between negative 3 and 4. The easiest number between negatives and positives is 0. Some of you might think that 1 is very easy. Fine, plug that in. I don't care, as long as it's between negative 3 and 4. So take that number that's between negative 3 and 4, so say 0 or 1, add 3 to it, you get a positive. Square it and then add 1, you also get a positive. Take that number, subtract 4, and then square it, you still get a positive because anything squared is positive. Positive times a positive times a positive is a positive. So now any number between, any x value I plug in between negative 3 and 4 is going to result in a positive y value. Now let's look at anything to the right of 4. So let's see, 1,000 plus 3 is going to be positive. How about 5 squared plus 1 is still positive. And then any number to the right of 4, bigger than 4, minus 4, and then squared is still going to be positive. So these are all positive values. Oh, and then I'm sorry, when we plug in 4, we got 0, because 4 minus 4 is 0, which would wipe out the rest. So now this sign chart tells me everything I know about the signs of f of x. Where the value or where the values will come out negative, where the values will come out positive, where the values will come out 0. So now I can answer parts A, B, and C. Part A, where will f of x come out 0? At x equals negative 3 and 4. Part B, where will f of x be positive? That would be, let's see, between negative 3 and 4, but not including. So negative 3 comma 4. And then again after 4 all the way out to infinity. So any number between negative 3 and 4 that I plug in, the f of x values will be positive. Not 0, positive. Then anything after 4, same thing. Part C, when will the x values that I plug in result in a negative f of x value? That's anywhere before negative 3. So negative infinity to negative 3, but don't include negative 3 because negative 3 makes f of x 0. Remember how we said that a multiplicity of a polynomial, of a 0 of a polynomial will make the graph either cut through or bounce off? So that's what's happening here. We have negative y values, like we said, before negative 3. Then negative 3 makes the function 0. Now, between negative 3 and 4, the y values are positive above the x-axis. Then, at 4, we hit 0, but then the values stay positive after 4, which creates this bouncing off effect. The y values are above the x-axis, go down to 0, and then stay above the x-axis. So that's a vague sketch of what that polynomial would look like, and we didn't use our calculator at all. The now try problem for for example 1 is number 1. Determine the x values that cause the polynomial function to be 0, positive, and negative. Well, if I'm looking for what sign the f of x values want to be, I'm going to use a sign chart. So I'm going to draw the number line, label that with what function I'm using, f of x. The, let's see, 3 zeros I have are negative 2, negative 1, and 5. Now I need to represent each quantity with a set of parentheses. I'm going to pick any number I want to the left of negative 2 on the number line, so negative 10 is fine. Negative 10 plus 2 is negative, negative 10 plus 1 is also negative, and negative 10 minus 5 is also negative. A negative times a negative is a positive, times another negative would be negative. So the resulting values to the left of negative 2 are negative. If I plug in anything to the left of negative 2, the y values come out negative. If I plug in negative 2, the y value will be 0. How about between negative 2 and negative 1? This is where it gets a little bit more tricky. I'm going to pick negative 1.5. Negative 1.5 plus 2 would be positive 0.5. Negative 1.5 plus 1 would be negative. And then negative 1.5 minus 5 is also negative. So I have a positive times a negative, which is a negative, times another negative, which makes the end results positive. Now, let's see. Negative 1, if I plugged in negative 1, one of the zeros, I get 0, hence it's a 0. And then anything between negative 1 and 5 I can pick to try and see what kind of outputs I'll get there. I'm going to pick the easiest number between a negative and a positive, 0. 0 plus 2 is positive, 0 plus 1 is positive, 0 minus 5 is negative, positive times positive is positive, times a negative is a negative. If I plug in 5, I get 0. Anything after 5, 1,000, positive, positive, positive. 1,000 plus 2 is positive, 1,000 plus 1 is positive, 1,000 minus 5, positive. My overall values are positive. So now I can answer parts A, B, and C. A, what x values cause the polynomial function to be 0? Those are x equals negative 2, negative 1, and 5. The zeros. Oh my gosh, coincidence? No. Alright, so then B, what x values cause the polynomial function to be positive? Those are the values between negative 2 and negative 1, and then again after 5, but you can't include any of those because those make the function 0. Part C, what x values cause the polynomial function to be negative? Those are anything before negative 2, so from negative infinity up to negative 2, but don't include negative 2. Then also between negative 1 and 5. I could also draw a vague sketch of this graph. If I had negative 1, negative 2, 1, 2, 3, 4, 5. Here's a 0. Here's a 0, here's a 0. I could probably find the y-intercept and the x-intercept, these are the x-intercepts. I could find the y-intercept, but I know this is a third degree polynomial, so I have opposite end behavior starting from the bottom left. All these zeros have an odd multiplicity, so they're going to cut through. So that's a vague sketch of the graph. The directions didn't ask for it. I'm just, being a teacher.